we are going through three-dimensional object representation, where we are trying to understand that whatever object in the real world we see, it can be represented in 3 dimensions. Okay, so sometimes it may be a boundary representation where you will specify with the boundary vertices, and you will specify that these are the boundary pixels or these things, and they cover your object, right? So these pixels in 3 dimensions, I believe you will understand, they will have 3 coordinates x, y and z. So such value for all these vertices together, such information will be helpful in understanding object. Similarly, this is a boundary representation, and another representation can be a space partition. A space partitioning. Here what happens? Here we represent in terms of the spatial region that has been partitioned or separate from the external environment. Here it may be something like contiguous solid cubes together kept to understand that it is a object. That may be one way. Okay. Apart from this, we are now starting something in boundary representation. One is Polygon Surface, where the surface of the object is a set of polygons. I should say the polygon surfaces. Okay, these can be represented either with Polygon Tables, plane equations or Polygon Meshes. So now let me tell you about Polygon Tables. Okay, so the first thing is Polygon Tables. It is very easy to understand that suppose there are certain vertices. Suppose we have two polygons. Okay, this is an object, suppose. So it is V1, V2, V3, V4, V5 and done. Let these edges be also named. I am naming them as E1, E2, E3, E4, E5 and E6. Okay, different color would have been better, but still it is understandable. The edges are E and vertex is V. Now here in Polygon Tables, what is happening actually, you have tables for each of these. One is the vertex table, okay. In the vertex table, you are maintaining the information of each vertex, V1, V2, V3, V4, V5. What are these? These are the vertices. It will have x, y and z coordinates. X1, Y1, Z1. similarly x2, y2, z2, and similarly for each vertex, which is x5, y5, z5. Okay, so this is, I should say, a list of vertices representing these are the vertices we have to represent our object. Okay, let me also note down the edges. Okay, so we have an edge table. In this edge table, you are storing the information related to edges, E1, E2, E3 through E6, right? So what is edge E1? E1 is between V2 and V3. So it is having the information V1, V2. E2 is where? V2, V3. Similarly, we have other edges as well. E6 is between V5 and V1. Okay. Having this information, let me write E3 as well. E3 is V3, V1, right? V3, V1. Having this information, so am I audible? We are representing something, the edges as well as the vertices, right? So vertex table like this, edge table like this, but is it helpful? Are we able to represent the polygon surfaces? Okay, so we have a separate table for polygon surfaces. Okay, I should say polygon surface table. In this table, you will be storing some information like what are the surfaces. In this object, you can see you have two objects. One is, if I am naming two surfaces, S1 as well as S2. I believe you will agree that yes, these are the two surfaces here. So in S1, if I store the information of S1 as the set of edges, it will be helpful. Okay, so set of edges for S1, it is E1, E2 as well as E3. So E1, E2, E3 makes one surface here. It is S1. Another surface is S2, and it is having is E3, E4, E5 as well as E6. Okay, this is another surface. So this was a simple object. If at all we would be having any other kind of objects, means any other objects where some more surfaces would have been there, in that case those surfaces also should have been written here. The next surface S3 as the sequence of your edges. Very simple. So this is how you will be representing one object as the set of polygon surfaces in a tabular format. So first of all, what you did, you kept the information of vertices, vertex V1 through V5, all the vertices in terms of their x, y and z coordinates, and then you wrote down the edges, all the edges with their vertex combinations, as E1 is between V1 V2. Having this information, now each surface can be represented as a set of edges or sequence of edges, whatever you think. So that is what we are representing here. So if you have here in this object two surfaces, we are writing S1 as a sequence set of these edges, S2 as set of these edges. Done. Now, having known about polygon tables, which is one of the way to represent an object in 3 dimension, another way can be plane equations. So before moving further, I will definitely try to ask about whether you have understood or not. Okay. In plane equation, what happens? We have the object will be having set of surfaces. These surfaces can be plane, means one surface here, if you are saying this is a polygon, maybe it is a plane, right? So each plane surface can be expressed with an equation. Okay, the equation will be ax plus by plus cz plus d is equal to 0. Okay. So now you are having this information. How can you solve? Okay, here in this equation you understand that x, y and z are the coordinates. However, a, b, c and d are the constant values. Okay, these constant values will describe the spatial properties of this particular plane. Okay, how can we find the value of this a, b, c and d? The only way to find the value of this is to solve it. And for solving this equation, I believe you understand that you will need at least 3 points. Okay, 3 points on this particular plane. Suppose these 3 points are also given. 3 points are also given. Since it is x, y and z, so you need 3 points, right? So 3 points, if at all they are given, x1, y1, z1, x2, y2, z2 and x3, y3 and z3. In that case, what you can do? You can form these 3 equations with these x values. Okay, you will take the d on this side, it will be minus d. Okay, so to make it 1, here you will take the d on the denominator side, this side. So if I am writing it something like a by d x1 plus b by d y1 plus c by d z1 is equal to minus 1. So if I am writing something like this, it is correct. Similarly, for all the 3 equations, right? A by d x2 plus b by d y2 plus c by d z2 is equal to minus 1, as well as a by d x3 plus b by d y3 plus c by d z3 is equal to minus 1. Having these equations, now you can find the solution of this equation easily, where you will find the value of a, b, c and d. For this purpose, you can use the Cramer's rule. So in Cramer's rule, you would have studied, or even if you don't have studied, it's okay. In Cramer's rule, what you will do, having this kind of equation, or for any such equation, ax plus by plus cz plus d is equal to 0, and given these 3 points, x1, whatever the 3 points, then you can have the determinants like this. A is 1 1 1 with y1 y2 y3 and z1 z2 z3, as well as you will have d. In b you will keep y as 1, you will keep x as it is, x1 x2 x3, y is what, 1 1 1, and z is as it is, z1 z2 z3. Similarly will be the case for c. You will keep z value as 1 1 1, and these two values x1 x2 x3 and y1 y2 y3. Also, what will be the value of d? In d you will have minus of the determinant of all of these, x1 y1 z1 x2 y2 z2 and x3 y3 z3. So now easily from here you can find the value of a, b, c and d. I believe you are able to understand how to find the determinants, right? What will happen? One is already gone. So for y1, if you are keeping y1, then it is these two values, so z2 minus z3, okay. Then if you are keeping y2, in that case these two values are there, so it is z3 minus z1. If you are keeping z3, in that case z3 into, sorry, y3 into, you will have z1 minus z2, okay. Similarly, okay, let me write for a, you can similarly find for others as well. So for a it is y1 into z2 minus z3 plus y2 into, it is z3 minus z1 plus y3 into z1 minus z2. Similarly, these things can be found for others as well, a, b, c and d, okay. So now you will have the values for a, b, c and d, and given any point you can easily find that whether it is on the surface or not. How you can find whether it is on the surface or not? If ax plus by plus cz plus d is equal to 0, then you can say that it is on plane or on surface, okay. If it is not equal to 0, in that case you can say not on the plane, okay. So if at all it is not on the plane, then either it will be, this value will be, let me write it separately, ax plus by plus cz plus d is either greater than 0 or it is less than 0, right? If it is greater than 0, it means this pixel, whatever x, y and z, x, y and z is outside of the plane, and if it is less than 0, then we say that it is x, y, z is inside of the plane. I believe you will understand that whatever in our example also, if this was a plane, so inside it, whatever if we have below this plane, it will be inside the plane, and other pixel may be outside of the plane. So for this value will be greater than 0, and for other pixel it will be less than 0. And if at all the pixel is on the plane, then it will be equal to 0. So this was the story of your plane equations. Okay, another way of representing your object. One more way we have noted down was your polygon meshes. Okay, it will be a mesh of polygon. Now, an important thing here in polygon mesh, let me start from beginning. In polygon mesh, what is happening? There are multiple polygons which will be there to form our object. Okay. Whatever object we are making, it can be made by these polygons, and such meshes can be represented here. Now, important thing here in the mesh is it is made. Okay, I should make it with triangle. Every one this line is joined with exactly two polygons. Okay, so okay, what else can I say? We have seen that in the polygon meshes, it is a mesh of polygons. These polygons may be a triangle, maybe a quadrilateral, other polygons as well. However, mostly you will see quadrilaterals or triangles, and triangles are the most used because it can be used to represent any kind of surfaces. Okay. Now, many of the things, maybe a complex object you are going to represent, you can definitely use this mesh of triangles to represent your object. This will certainly help to represent your object in a correct way. Okay.